Hello everyone, welcome back to PMAC1105. In this video, I will be talking about application of quadratic equation. As you learned in the previous section, you learn what the quadratic function is. You learn the standard form and the vertex form of quadratic function. In this video, we'll be focused on the application of quadratic equation and quadratic function. Quadratic equation and quadratic function is one of the most important equation in college algebra. It can be used to model many word application problem, especially problem in physics. So today I'm going to give you some word problem related to and how to set up a quadratic equation to solve word problem. Okay, so let's get started. Section 3.4. Section 3.4 application of quadratic function. Okay. One of the most important application of quadratic function in physics is used to implement and used to portray the motion, the projectile motion. Okay, so I'm going to give you example related to projectile motion and how we're going to do the problem and how to answer a question in projectile motion. Okay, so we're gonna go straight to, I think we're gonna go straight to example. Okay, so first of all, we talk about projectile motion using quadratic equation and quadratic function. So I have a problem like this. Most of the projectile motion give you the quadratic equation or quadratic function already. You just need to use the equation given and function given to answer the question. For example, a golf ball is hit so that its height h, so h is mean height, in feet after t second, so the unit is feet after t second. We don't know how many seconds, but it just say t second is given by. So they give you the function, the height function in terms of t, negative 16t plus 60t. Okay. Part A. What is the initial height of the golf ball? Initial height of the golf ball. Part B. How high is the golf ball after 1.5 seconds? Okay, after 1.5 seconds. And part C, find the maximum height of the golf ball. Find max height of the golf ball. Okay, solution. So let's see how we're gonna answer this question here. First of all, this is a projectile motion. So this is just imagine this is the ground, right? It's the ground, and the golf ball is here, right? And you're gonna hit the golf ball, and it's gonna, the path will be in a parabolic curve. Okay, so the path of the golf ball go like this. Okay. Okay, let's go like this. It's gonna be over here after t second, but we don't know how. And the maximum point is here. Okay, so it's kind of go up like this. Okay, all right. So they ask you to find initial height. Okay, so this is the height. This is the function in terms of height, and this function is quadratic function. Initial height, it means in order to get the height at time t, because it's initially it means t equals 0. Okay, t equals 0, so h, we're going to plug 0 into this equation function, so you can have 0 square, right, plus 6t times 0, so it could be 0 feet. It means what? It means initial height, which is it will be on the ground. So initially the ball is on the ground. The ball is on the ground. Okay. Part B. How high is the golf ball after 1.5 seconds? This is the function in the term of t. The function, this is function h in terms of t. So after 1.5 seconds, you're gonna plug 1.5 in. So you have a negative 16 1.5 square plus 6t times 1.5. So go ahead and calculate this out. So they give you the height in feet. Okay, I don't have calculator here, but everybody can go ahead and plug it in, yeah, to get this. For part C, the maximum height, I mean the maximum point right here, right? They ask you for the maximum point right here, the height right here. Okay, so the maximum point over this is the vertex of parabola, and this is upside down parabola. In order to find vertex, you're going to use the formula, the vertex formula. So x equal negative b over 2a, right? But x will be, x in this case is t, because it's our function is in terms of t. So basically we want to find the t at maximum point. So the t over here will be what? T equal negative b will be negative 6t, right? Over, so b right here, over 2 times negative 16, it will be 6t over 32. If we simplify this, now let me see, let's simplify this with 30, let me see, divided by 4, right? 60 will be divided by 4 give you what? 60 divided by 4 give you 15, right? And 32 by 4 give you 8. So 15 over 8 seconds. So after 15 over 8 seconds, you can convert it to decimal, I don't mind, okay? Because this is the second, it's time. After 15 over 8 seconds, the golf ball will be right over here. Okay, it will be right over here. Alright. But this is that is t. We want to find a height, we have to plug 15 over 8. So h of 15 over 8, you're going to plug into this, so you have 16, 15 over 8 square, right? Plus 60 times 15 over 8. Alright. So after you, okay, you're going to put into calculator, you're going to calculate, and it's going to give you the height, okay, in feet. And I don't know how high it is because I don't have a calculator here, but you can go ahead and find it yourself, okay, easily. Okay, so that is one of the application of quadratic function, quadratic equation. But you see in this problem, right, in this example, they give you the function already, but some example we have to find the function. Okay, some example we have to find a function by using Pythagorean theorem. So in the second example, we're going to apply Pythagorean theorem to set up a quadratic function. Setting up quadratic function with function by using Pythagorean theorem. Okay, Pythagorean theorem. Okay, you remember the Pythagorean theorem is a squared plus b squared equal to c squared, right? So Pythagorean theorem is actually in second degree. Alright, if we apply Pythagorean theorem to set up the equation, then our equation must be in second degree, and if it is in second degree, it's nothing but a quadratic function, right? Okay, now let's take a look at this one. Let's take a look at this one. I have a piece of property in the shape of the right triangle. Piece of property is in the shape of a triangle. It's a shape of a right triangle. I'm sorry, this is a shape of a right triangle. Okay, and the longer leg is about 20 meters longer than twice the length of the shorter leg. So the longer leg is about 20 meters longer than twice the length of the shorter, and twice the length of the shorter leg. Okay, so this kind of because this is application, it's a word problem. So you remember when you do application for linear equation, it's kind of the same thing. You gotta read a problem, and based on information from the problem given, you have to set up the equation, right? But the equation in this case will be quadratic one. Okay, the length of the hypotenuse, hypotenuse is 10 meter longer. Is 10 meter longer than the length of the longer leg. Then the length of the longer leg. Okay. Find the length of each side of the triangle. Alright, find the length of each side of property, which is of the triangle. Alright, so let's see how we're gonna do this. Let's draw the picture. Okay, this is a word problem. So I have a piece of property in the shape of right triangle. So I have a right triangle like this. Okay, so this is a right triangle. Okay. Alright, the longer length is about 20 meter than twice the length of the shorter leg. So if I call this the shorter leg is x, so the longer leg will be 20 plus twice the length of the shorter will be 20 plus 2x, right? The length of the hypotenuse is 10 meter longer than the length of the longer leg. So it will be 10 meter longer than the length. So this is the length of the longer. So 10 meter plus 20 plus 2x. So it will be just 10 more 20 meter longer than. Okay. Which is in this case will be 30 plus 2x. Alright. Now we have this is a right triangle. Now we can set up the equation by using a Pythagorean theorem. Okay, so the Pythagorean theorem says that the longer leg square, which is 20 plus 2x squared, plus the shorter leg square, which is x, will be equal to the hypotenuse square, will be 30 plus 2x. I'm sorry, so this is 2x plus 2x totally squared. Okay, now if we go ahead and expand this out, go ahead and expand, so this give you what? It's gonna give you 400, right? Plus 80x plus 4x squared plus x squared equal to 900, right? Plus 120x, right? Plus 4x squared, right? Okay, so 400 cancel, I believe so. So what we have left is 400 plus 80x plus x squared equal to 900 plus 120x. Now I'm going to move everything to the left hand side so that we have 0 on the right hand side, so that we have quadratic equation. So you have x squared. 80x minus 120x will be give you negative 40x, and minus 900 both sides give you negative 500 equal 0. And this quadratic equation here, we have to check if it's factorable or not. So go ahead and try to factor this. Equal 0. Okay. Alright, so we're gonna try to do a try and error method. So this x here, so factor of 500 so that you add up give you 40, which is what? Will be 50 and 10, right? Very easy, will be 50 and 10. Okay, then from here we can go ahead and split it up by zero product property. Okay, plus 10 equals 0. And x could be equal to 50 and x equal to negative 10. X cannot be negative, so this is not good. So my final answer will be this: x equal 50 meters. Okay, so the shorter leg will be 50 meter. The longer leg will be what? Longer leg will be 50 times 200 will be 120 meter, and the hypotenuse will be what? Will be 50 times 200, right? 100 times plus will be 130 meter, and that's so. Okay. Good. Excellent. Another example also related to Pythagorean theorem will be something like this. So this, I'm going to put example number 1. So the next one will be example number 2. Alright, so I have a problem like this. I have a kite. Okay, is flying on 50 feet of string. Is flying on 50 feet of string. Okay. How high is it above the ground? Above the ground. If its height is 10 feet more than the horizontal distance. If its height is 10 feet more than horizontal distance. Okay.
Các bạn gì đâu, nó vậy gì.
More than horizontal distance from the person flying it. Okay, from the person flying it. Period. Okay. Alright, so that's the if the height is how high is it above the ground if the height of which is 10 more than the horizontal distance from the ground. Okay. Alright. Solution. So let's draw the picture first, okay? So they had a person like this, so it's just a person standing on the ground like this, right? And he had a string with a kite, so the kite is kind of over here. Okay, so this is the kite. Okay, and this is 50 feet. Okay, how high is it above the ground? If its height is 10 feet more than horizontal distance from the person. So horizontal distance is this. So this is the height of the of the kite, and the horizontal distance is this. If its height is 10 feet more than horizontal distance. Okay, it's 10 feet more than horizontal. So over here, this horizontal distance is x, right? So it's will be 10 plus x. I mean, my picture is not really good because you see the how come 10 plus x is greater than x. So if you want to refix the picture, you just make it something like this. Alright, so it will be 10 plus x here, and over here will be x, right? So is that correct? Oh no. How high is it? Let me erase it. So have to read carefully. So how high is it above the ground if its height is 10 feet more than horizontal distance? 10 feet more than horizontal distance. It should be, yeah, it should be that, because it's 10 feet more than this is horizontal distance. All right, and 10 feet more. Okay, so my picture is not quite it's not really scale. So I mean, so it should be something like this. It should be something like this. It's better. All right, so this is 50 feet here, and this x here, and 10 plus x. So when you draw the picture, it doesn't have to be like 100% correctly. So just kind of relatively correct, so that you understand what is really going on and what is say in the word problem here. Okay, so in order to find the height, right? So you need to find x, right? So this is a right triangle, so we can set up the right triangle. So x squared plus 10 plus x squared equal 50 squared, right? And from here I can expand them out, so have x squared plus 100 plus 20x plus x squared equal 50, right? Alright, so x squared cancel out. So you have that's something correct? 10 plus x squared 20x. Oh, 50 squared is 2500. Okay, so it will be 20x equal to minus 100 will be 2400. So so x could be what? X could be equal to. So I don't have enough space. I'm gonna move over here. Okay. So x could be 2400 over 20, so it cancel. It could be 60. All right, so 60 feet. That's 60. Something. No, it's something not right. Something not right over here. So let me 200. Let me look at it again. 20x squared. Oh yeah, something not right over here. Just go ahead and cancel the x squared. It doesn't make sense. So I'm sorry. So I'm gonna erase this. So I'm gonna erase this. I don't know why I just cancel x squared. So the x squared plus x squared. All right. So it give you 2x squared, right? So I erase this. So you're gonna have 2x squared plus 20x minus, erase this, minus the 2400, right? Equals 0. Here you go. So I have a quadratic equation here. So I'll go ahead and simplify by 2. So I have x squared plus 10x. Simplify by 2, so you have negative 1200 equals 0. Alright, so this one I can factor them out, will be x, right? It will be 40 and negative 30 equals 0. So one of them should be eradicated. So you have x equal 30 feet. Okay, so x equal 30 feet. Then this over here must be 40. So this is be equal to 10 plus 30 equal to 40 feet. And that's it. Okay. So again, quadratic function can be implemented in many word application. For example, it can be used when you want to find the volume of the cube or the volume of something, especially the rectangular cube. So we can find the volume of the box. So the volume is what? The volume is length time width time height, right? So just think about it. It's going to give you a quadratic equation over there. Okay. And yeah, most of the time you see a quadratic function will be in projectile motion. So maybe on the test I'm going to give you something with Pythagorean theorem and projectile motion. If I give you the projectile motion, then I give you the function already. So I think the most important one will be the setting up quadratic function by using Pythagorean theorem. So I'm going to give this on the test. Okay. Of course, the problem is not going to be 100% like this. I'm going to change. I'm going to change the problem, but you have to use the Pythagorean theorem to set up a quadratic equation. Okay, so I think that's all for section 3.4. I'm gonna stop right over here and let me know if you have any question. I'll see you guys next time. Bye bye.